Hi, welcome to this video. In this video, we'll discuss finding domains symbolically, which just means we're going to look at the function instead of the graph. So in some previous activities, we've looked at the graph and we would decide on domain based on the graph, the visual part of the function. But now we're going to learn how to look at just the function and figure out how that domain should work. The first ones we're discussing here are square root functions. And just as a reminder, we have covered the square root function as the graph, and we know how that looks. It starts at 0, 0, and then shoots off to the right there, okay? And that basic function just has a domain of 0 to infinity with a bracket on the 0. Because everything inside this root right here needs to be positive or 0, okay? So you can take the square root of 0 or you can take the square root of something positive, but we can't take the square root of a negative quantity. So that is how you're going to proceed with these, is you're just going to take this inside part of the function and you're going to set up an inequality saying that this quantity has to be greater than or equal to 0, solve for the variable, and this will tell you what your domain needs to be. And if you like to look at things visually, you can graph that. So you can mark 4, and then that'll be a closed circle, and then everything to the right. Okay, and then we're going to use interval notation to state the domain. So it'll be bracket 4 to infinity. Okay, so as long as I pick numbers that are 4 or bigger and use those for my x values, I will always get something that works in this square root function, okay? So we're basically just finding the values that actually work in this function, okay? There's some restrictions, there's some things we can't use, all right? And so when you find the domain, you're stating what you can use for the function. All right, so for this next one, for the g of x function, you just want to take the 3x plus 8, set it greater than or equal to 0, and solve. And you're going to get x is greater than or equal to negative 8/3. You want to graph that, mark the negative 8/3 on your number line. That would be a closed circle, everything to the right. In interval notation, you would have bracket negative 8/3 to infinity. Okay. All right, this last one here, the variable inside, the statement inside is a little backwards, okay? So you got to watch out for these. If you take this and you set it greater than or equal to 0, and then you solve for x, you subtract the 5, and then you have to divide by a negative 1, which flips that inequality sign. So be careful that you do that. A lot of students will forget that. Okay, so that inequality sign should flip. And then if you look at the graph over here, then you've got 5, and that's everything to the left. All right, so our domain for this particular function would be negative infinity to 5 with a bracket on the 5. And remember, this is telling us numbers that we can use. So like, for example, if I used, say, a negative 20, okay, for x, so if I want to plug in a negative 20, so you'll say 5 minus negative 20. All right, then you would get a 25 inside there because you're subtracting the negative, and then you can take the square root of that and get a 5, okay? So it seems a little backwards, right, that we can use negative numbers in this function, and it works because it's a square root function, but when you're subtracting the negative, then it gives you that positive. So these are our numbers that we can use for the h of x function, okay? So cube root functions are a little different. If you think back to the cube, like the basic cube root graph, okay, it looks kind of like this. You've got two curves. It comes through the origin and it sort of shoots off. Sort of looks like the square root graph, but then it looks like it's kind of going both directions, right? So your regular cube root function, you can have positive values for x, you can have a 0 for x, you can have negative numbers for x. So all of those different values work. So with cube root functions, you don't have any restrictions on your domain. because you can plug in positive and negative numbers and take the cube root of positive and negative numbers. So this guy right here just ends up being any number goes, if you want to look at the number line, okay, and negative infinity to positive infinity is your domain. Okay. So rational functions, we now have variables in the bottom of the fraction, okay? And we know that the bottom of a fraction cannot be 0, right? So if you have, a fraction where you say that like 10 over 0, that's an issue, or -5 over 0, that's an issue because you can't divide by 0, okay? So you can have a 0 in the top, right? It's okay if I had a 0 over 10, that's fine, or a 0 over -5, that's fine. It's just when you have the 0 in the denominator that you have an issue, all right? So if you look at right here, okay, if I was to use a -3 right here for x, and I did -3 plus 3, then I would get a 0, and I would have a situation where I have a 0 in the bottom of the fraction, okay? So essentially what we want to do is make that a restriction, right? So you want to kind of think about that x plus 3 cannot be equal to 0, which means that x cannot be equal to -3. And then if you're thinking about a number line, that would be an open circle at -3, but everything else to the left and the right is okay. All right, there's no restrictions on this x in the top here because even if you had a 0 for that x, 2 times 0 is 0, but remember you can have a 0 in the top of a fraction. That's fine, okay? So then you could just use this number line here to write your domain. So it's going to be -infinity to -3, use a parenthesis on that -3, union -3 to infinity. Okay, and by using the parentheses here on both the -3 and the 3, I am showing basically I can use anything except for -3. Okay, so let's go down to number 6. Now, in the g of x function, what you have here in the bottom is a binomial that can be factored. So if we factor that, we have a difference of perfect squares here, and you factor that using 2x and 2x, and you use 7 and 7, and then one binomial needs to be plus and one needs to be minus. Okay, so anytime you have something that can factor, you want to make sure you get that factored, all right? And then you want to look at whatever happened in the bottom here, and you want to set each of those factors so that you're stating that they cannot equal 0. So 2x plus 7 cannot equal 0, and 2x minus 7 cannot equal 0. Okay, and then you can just think of solving these just like a regular equation. So you're getting x cannot be -7/2. And then down here, you're going to get that x cannot be +7/2. Okay, so then think of marking those on your number line, -7/2, +7/2, open circles at each of these, but anything else is okay. Okay, anything else is okay. All right, so remember on the top here, there's no issues with, even though there's a variable on the top, there's no restrictions that we have to worry about because we can have a positive number in the top, negative number in the top, or a 0 in the top. So we only have to worry about the bottom, the denominator, and then just use your number line to write out your domain. So it's going to be your -infinity to -7/2, your middle section, which is -7/2 to 7/2, and then this right section, which will be 7/2 to infinity. Okay, and this would be your domain. Okay. Now down here, these are where we're combining different ideas together. Okay, these get a bit tricky, so you got to be careful. So on this particular one, we've got a square root function, okay, on the top, and we have a rational function on the bottom. So we've got two different issues going on here. So we've kind of got what we were dealing with at the beginning here. These were your square root functions. And then we've got a rational function, what we were just dealing with in the previous section. So we have to put all those ideas together to decide on the domain. So I know that x plus 4 has to be greater than or equal to 0 because of the square root function, which tells me x has to be greater than or equal to negative 4. And I also know that x plus 3 cannot equal 0 and x minus 5 cannot equal 0 because they're on the denominator. So x cannot equal negative 3, x cannot equal 5. And then you want to think about all of these on your number line. So we've got a negative 4, we've got a negative 3, we've got a 5. And you would have open circles at the negative 3 and the 5 because x cannot be those numbers. You would have a closed circle on the negative 4, and then you want to think of graphing anything to the right because greater than or equal to negative 4 would be numbers to the right. So you want to fill in all of these spots to the right, skipping over the negative 3 and the 5, okay? And then just use this number line to write your answer. So it's going to be bracket negative 4 to negative 3 with a parenthesis on the negative 3, union negative 3 to 5, parenthesis on both ends there, union 5 to infinity with parentheses on the 5 and the infinity. So you can see here where when they combine, right, when they combine these functions, these ideas, there can be a lot of different things to think about. So these are the ones you're really going to need to slow down and make sure you're thinking about all the different parts of the function. Okay, lastly, we have another situation where they're giving us a root function, right? So they gave us a root function, but it's in the denominator. So that actually creates another concern, and we also have this x down here in the denominator. So we need to worry about both of those issues, okay? So first of all, x cannot equal 0, okay? So since you have this x sitting out front here, you need to think about the fact that that cannot be a 0, because if you had a 0 here, that would zero everything out on the bottom and create a 0 in the denominator of that fraction, which would not be okay. Now, normally with root functions, we take what's inside the root and we set it equal to greater than or equal to 0. But in this particular case, since this is in the denominator, okay, we actually cannot use the greater than or equal to. We have to just use the greater than because we actually can't have a 0. We can't have this come out to be 0. But we can still have it greater than 0. That would still work. So you're going to get x is greater than 5, okay? So be careful, okay, when they put those root functions on the bottom of a fraction like they did here, you need to change your inequality to just a greater than sign. All right, and then if you'll mark those numbers on your number line, you've got a 0, and you would have an open circle at 0, and then you've got greater than 5. So that would be open circle at 5 and everything to the right, okay? And then you combine these ideas together, and basically what you're going to need to use for your domain is going to be parentheses 5 to infinity. All right? So these take a lot of practice, okay? So it takes practice, all right? And that's why you'll do practice problems in your lab manual and WebAssign and so forth, okay? And have fun with your math, and I'll see you in the next video.